Hello students, in this video lecture I am going to discuss the numerical example on the properties of S parameters. So you can see the problem definition here. The S parameters of the two-port network are given by the S matrix is given here. It is a 2 cross 2 matrix and they asked to prove that the network is the reciprocal but not lossless, and also we have to find the return loss at port 1 and port 2 is short circuited, right? So now I will write down the given S matrix here. So what is the order of this matrix? The order of the matrix is 2 cross 2 since it is 2 port network, right? So I will write in once again I will write down the S matrix here. So matrix given is 0.2 with 0 phase, that is phase angle is 0, 0.6 90 degree, 0.6 90 degree and 0.1 0 degree. So this is my S matrix, right? And here we have to prove the given network is the reciprocal but not lossless. Let us check for the first property, that is whether the network is reciprocal or not. So what is the necessary condition to check for the reciprocal network, right? The condition is if the matrix S is equal to its transpose, that is S transpose, then the network is reciprocal network, or else it is not. It is a non-reciprocal network, right? So already we have S matrix. So let us take the transpose of S matrix. I will write down the S transpose here. S transpose means what? The rows of the matrix becomes what? Column. So this row becomes what? Column. That is 0.2 0, next 0.6 90 degree, next this second row becomes second column, that is 0.6 90 degree and 0.1 0 degree, right? So look at the matrix S as well as S transpose. Are they identical both? Yes, the matrix S and its transpose, they are identical, right? Therefore the given network is reciprocal. The given network is reciprocal. And also we have to prove it is a lossy network. Not lossless means it is a lossy network. So what is the condition to be satisfied the network is said to be lossless, right? The condition is what? There are two methods you can follow to prove the given network is lossless. The first one is what? Summation I is equal to 1 to n, I is equal to 1, S I n square is equal to 1, right? Where I is equal to n is what? The number of ports. How many number of ports are there? 2 ports are there. So summation I is equal to 1 to 2 S1 Si n is Si n is there. Okay. S11, sorry, instead of writing like this, we'll do S11 square plus S12 square is equal to 1, right? So we have to prove the squared magnitude of the elements of the first row or the squared magnitude of the elements of the second row is equal to what? 1, right? So what is S11 here? S11, the magnitude of S11 is nothing but 0.2 square plus the squared magnitude of 0.6, so it is 0.6 square, right? E is equal to 1, we have to check, right? So 0.2 square means it is 0.04 plus, which is 0.36. E is equal to 1? No, it is not equal to 1, because 0.36 plus 0.36, how much it is? It is 0.4. It is not equal to 1, right? Therefore this matrix is not lossless, it is a lossy network. Similarly you can check for the second also. 0.6 square plus 0.1 square, which is equal to 0.36 plus 0.01, which is equal to 0.36, 0.37, which is also not equal to 1, right? Therefore the network is lossy network, it is not a lossless, right? Another condition you can also follow is the network is said to be lossless if it satisfies the condition S conjugate, the conjugate of S matrix multiplied by its transpose, S transpose, if it is the identity matrix, that is unitary matrix, then you can say the S matrix or network is lossless, right? So what is the conjugate of this one S matrix? I will write down here. Conjugate of S matrix is 0.2. Conjugate means the phase angle becomes positive, phase angle becomes negative, and negative becomes what? Positive. So this is 0 degree, so I will keep as it is. Then 0.6, it is plus 90 degrees there, so this becomes minus 90 degree. Next 0.6 minus 90 degree, and here it is 0.10 degree. So this is my S conjugate, and here S transpose. So this is my S transpose, you write here 0.2 0 degree, 0.6 90 degree, next 0.6 90 degree, and 0.1 0 degree, right? So you multiply both these matrices. So what is 0.2 into 0.2? So this row you have to multiply it with this column. 0.2 into 0.2 is what? 0.4, 0.04, and here angle is what? 0 is there, so it is 0. No, 0 means you write as it is, plus 0.2 into 0.6, right? It is 0. Multiply 0.2 into 0.6, you will get some value, but unitary matrix, the first element is always what? 1, so this is not equal to 1. Therefore the network is lossy network, it is not a lossless network. And the second question is, find the return loss. Find the return loss when at port 1 when port 2 is short circuited. So how to find that? Yes, so the return loss formula is return loss is equal to minus 20 log to the base 10 and mod of tau 1, right? What is this tau 1? Tau 1 is the input reflection coefficient. So return loss is equal to minus 20 log of input reflection coefficient tau 1, right? And for mismatched load, we know the formula for input reflection coefficient tau 1 is equal to S11 plus S12 square tau 2 divided by 1 minus S22 tau 2. So please remember, reflection coefficient reflection coefficient, the reflection coefficient at the output side tau 2, when it is short circuited, its reflection coefficient is always equal to -1. So this you have to remember here, tau 2 is equal to -1. Therefore, what is S11? The first element of the S matrix. What is that? Is that 0.2? Yes. So S1 is equal to 0.2 plus S12 square, right? So what is the second element of the first row, S12, right? It is nothing but 0.6 with phase angle of 90 degree, and that can be written as what? In polar form, phasor polar form 0.6, and 90 degree can be written as what? E raised to j pi by 2. 0.6 and phase angle is e raised to j pi by 2, and here it is square, S12 square, this square into tau 2 is nothing but -1 divided by 1 minus S22. What is the last element? Second row, second column, last fourth element is how much? The value is S22 is equal to, is that 0.1 into what is tau 2 value? -1. Therefore 0.2 plus and here this -1 is there, so this I will make minus, then 0.6 is there, 0.6 is there. What is e raised to j pi by 2? It is cos pi by 2 plus j sin pi by 2. Cos pi by 2 is 0 plus sin pi by 2 is 1, so it is j, so its value is equal to what? J. So it is, here I will write j whole square, and this -1 is multiplied with plus, so this becomes minus divided by 1 minus, this minus into minus becomes what? Plus, so it is 0.1. Therefore, so here it is 0.2, see here 0.6 square j square value is -1, and this -1 and this -1 is plus, divided by 1 plus 0.1 is 1.1, that is equal to 0.2 plus 0.6 square is 0.36 divided by 1.1. So if you simplify this one, you will get tau 1 is equal to how much? 0.5273, 0.5273, right? And therefore return loss RL, which is always measured in decibel, -20 log to the base 10 tau 1. What is the value of tau 1? Which is 0.5273. So calculate what is -20 log of 0.5273 to the base 10. You will get return loss is equal to how much? 5.56 dB. So this much return loss you will get at the port 1 when port 2 is short circuited. Whenever there is port is short circuited, the corresponding reflection coefficient is -1, right? If the input port is short circuited, then tau 1 is equal to what? -1. You have to calculate tau 2, right? So this is the example. Here we proved the network is reciprocal because S is equal to S transpose we got. The second point is we proved the network is lossy, means the network is not lossless because the S conjugate multiplied by S transpose is not equal to identity matrix, right? So that is the second point. And the third point is what? We have calculated the return loss at the port 1 when port 2 is short circuited. Is that clear? Okay. So I will give one more example you can solve. So the same, only the matrix is different, the concept remains same. So I will give the matrix. So matrix S is equal to, so it is 4 port network. 4 port means the matrix size of the order of 4 cross 4. So here it is 0.1, 90 degree, 0.8 45 degree, next 0.3 45 degree, next 0. Second row elements are 0.8 45 degree, next 0 is there, 0 is there, 0.4 45 degree, next 0.3 45 degrees there, next 0 0, here it is 0.6 45 degree, and the last row elements are 0, 0.4 45 degree, 0.6 45 degree, and here it is 0. So this is the S parameter of 4-port S matrix of 4-port network. So here you have to prove or find the network is the network reciprocal and lossless. You have to find whether the network is reciprocal and lossless, and also you have to find what the return loss at port 1 when port 2 is short circuited, right? So this is a second example, this is the assignment, right? So I will give the hint. To prove reciprocal, the condition you have to check is the matrix S is equal to its transpose. If this condition is satisfied, then the network is reciprocal network. The second is if the sum of the squared magnitude of all the elements of the first row, right, that is 0.1 square plus 0.8 square plus 0.3 square plus 0, right? So if you get S11 square plus S12 square plus S13 square plus S14 square is equal to 1, if you get 1, then the network is lossless. If it is not equal to 1, then network is what? Lossy network. And the third one, you have to use return loss RL is equal to minus 20 log input reflection coefficient tau 1, and the tau 1 formula you know, right? S11 plus S12 square tau 2 divided by 1 minus S22 into tau 2, right? Hope you will solve this example. Thank you.